So today I'll be representing on the responsible use of publicly scraped data to fine-tune large language models. And to be much more specific, we'll just look at what I had developed, which is a responsible AI framework for using publicly scraped data to fine-tune large language models in a productization use case. So this is in when you're developing certain products, being it for commercial purpose, being it for academic purpose, or even for a hobbyist purpose, and what it means to do so responsibly according to current trends in responsible AI and privacy rules that you must follow as well. And I'm Joachim Asare. I'm a graduate student at Harvard University, specializing in machine learning engineering, and much more specifically with the implementation of responsible AI. And glad to meet all of you here. Feel free to send in your questions into the chat box and attend to them. Okay, so let's just start with this. So first of all, what are, there are numerous applications of using publicly scraped data in terms of building systems, AI systems to be specific. So for example, you may want to scrape Amazon product reviews for certain consumer insights, where you're going to use that to perhaps build some tool that would make product recommendation, but that would definitely first start from you scraping this, publicly available data. You may also want to scrape some content from Google in order to build, SEO tools to provide insights on perhaps how a user searches for specific products or make certain query or trends. And we use this information to build other, SEO kind of related applications. You have other use cases like maybe scraping data from TripAdvisor in order to build some automated, personalized, travel itinerary based on user preferences and other, trending destinations that they may want to visit as well. And maybe even scrape Reddit, which was even related to a recent project I worked on where we scraped conversations on Reddit and used that to be able to predict certain needs that people have in terms of developing products. And we built a great application using this for a consultancy, which is mainly into product design. Another very good use case. A last popular example of a good use case would be, scraping LinkedIn to build a lot of these AI recruitment platforms or job, matching platforms. So we can go on and on. There are several applications of, scraping publicly available data. And what we use this is we end up cleaning this data and then use that to fine-tune existing large language models. In context of today's presentation, when I talk about training large language models, I'm being much more specific to fine-tuning. So we are not talking about necessarily building a foundation model, but with the existing models that are out there, which we do, what happens is that we pick up these models, whether via API or the model itself, these weights themselves, and then fine-tune them for a particular use case. So this presentation is focused on acquiring and how we should acquire and use, this publicly available data to fine-tune these models for such use cases. Now, already, once we decide to use this publicly available data, there are already inherent issues with such publicly scraped data that we should be aware of even before we use them to fine-tune these models. And I'm going to go over them in terms of 4 key issues. The first one is with respect to privacy and consent. So interestingly, and I'm sure most of us here know this, most of some of the data, online are you have them in a way that users are not even aware that this data or this personal data that they have is publicly online. And you may not be aware of that because you're just scraping this data, but the users themselves may not be aware of what their data is explicitly being used for. And we'll look at ways to, sort of mitigate this kind of complex issue. What's a kind of safe way to go around this in terms of the issue with privacy and consent, which is inherent with, some of the data that we scrape. The next is with the data quality itself. This is a popular problem that, a lot of data scientists work on. And that is with respect to the fact that given the use case of the data that you are going to apply to, or the kind of application that you have, or use case for that data, what happens is that some data would be unwanted, some data would even come in a form that is unstructured, and even some data may contain misinformation. And so data quality is a very big issue. I always say that what is noisy data is, is context specific, because we just say noisy data, but with respect to the context. For example, if we're scraping, just as I said, information from LinkedIn and using that to help with maybe knowing jobs that are out there and the job descriptions that are available, you may have, maybe some information about certain users that are embedded within that data that you scraped, which is unwanted. In that case, that information is noisy. But maybe in another use case where you may be thinking about certain characteristics of users that apply to those roles, then that information may be useful. So when we say noisy, it's something that is, very context specific. But once again, data quality also being, a key issue that is inherent within the data that we use to fine tune these large language models. Another one, which is also quite difficult to battle with, is inherent bias. You may have the representation of a certain user group within the data that you're working with. Um, let's say you're scraping subreddit information. Perhaps for the application that you are using it for, it is important to know the demographic, of the users that you're working with. So, for example, if it's overrepresenting a large population of people that are, I don't know, maybe young, between the ages of 20 and 30, you should be aware of that existing bias, that this is coming, this information is not an information that just represents, all ages, but with respect to this particular use case. So just as I spoke about noise, bias is also another very context specific use case, because you wouldn't say overrepresentation if you are interested in that user group. So it's another key issue that is in there with respect to the data. You may be having the opinions of only a particular user group. It could be race, it could be age, it could even just be with respect to the source that you are getting that information from. And this is what leads to a biased, or what people refer to as an unfair model. And I once again, in the context of responsible AI, even just AI generally with respect to the terminologies that we are using here, I know very well that there's a lot of misinformation that is out there, or wrong ways that we define certain things. So I would emphasize on some of these definitions. Once again, as I mentioned, when we talk about bias, we talk about, a model being unfair is very context specific. It could be fair in one context, but unfair in another context. And it's just about we understanding how we use the data, understanding the domain of that data, understanding, the source of that data that we're using to fine tune these models. A last, categorized key issue that I have in here is data leakage, where inherently we can once again also have the risk of the models, unintentionally memorizing certain information that is in there. Sometimes certain personally identifiable information that may be in there. And you can end up having a lot of cases where you can prompt these models to pull out this personal information. And I'll demonstrate that shortly. Now, based on all these key issues that I spoke about with respect to issues that once we just, scrape this data, we could have inherently with this data, or we could have embedded within this data, is the fact that should tell us that we don't want to just dump in this data. So I have this interesting phrase I call, like, if you just dump in the data as it is without, taking time to go through this data, trying to predict what are these privacy, consent issues, data quality issues, even biases that may be with that data, and risks of having PII information that is in there, what you're going to have is what I call a dump AI, where you can end up, fine tuning a model that is now focusing on certain aspect of the data that you wouldn't want to focus on, certain aspect of the data points maybe being overrepresented over other data points. So once you just dump in the data, you're definitely going to have dump AI. You're not really sure what your model is working with. You're not really sure of what kind of data point is focusing on. And most of the issues that we have, even with large language models, is just because we have there's a large chunk of data that we've, put in there. And today, that is why you have techniques like retrieval augmented generation, like RAG approaches that try to enable the models that we are using to be much more context specific on some data base that we have of like data that we want you to be focused on to. So once again, if you just dump in that data, you're going to have dump AI. I'm going to start with this interesting video. I just want to pay attention. Let me just a second. Let me know if you can hear this in the chat box. If anyone can't hear, just let me know.
We built glasses that let you identify anybody on the street. The information a tool collects from just a photo of your face is staggering. To use it, you just put the glasses on, then as you walk by people, the glasses will detect when somebody's face is in frame. This photo is used to analyze them, and after a few seconds, their personal information pops up on your phone. Hi, ma'am. Wait, are you Betsy? Oh, okay. I think I met you through like the Cambridge Community Foundation, right? Yeah. It's great to meet you.
So these were some Harvard undergrad students. I even know one of them personally, and this was some information that was going viral a few months ago. So what they did was that with the Meta Ray Bans that was released, which have a multimodal model in there that is working with, what happens is that they had been able to hack into this Meta glasses, and once they just where they approach someone, able to pull up a large chunk of like information that is live script from online and use that to talk to them like they know them already. So this is the guy, meeting this woman at the train station and just saying, hey, I think I've met you before. This is your name. This is where you live and all of that. Now think about this, in the hands of potentially criminals, where you can use this to commit a lot of fraud, use this to commit a lot of crimes in terms of pretending you know someone just because of their PR information. And this video, I just wanted to use that as a very, very good use case of how when we have a lot of PR information on there online that can be accessed very easily. And so when we are scraping data, we want to be very careful about it, because once we hand over these tools to clients and other users, we are not really sure of how it's going to be used. We are not really sure of how it's going to be deployed and in whose hands it's going to get into. And so in as much as most people here may just be data enthusiasts in terms of just scraping, we should really be concerned about how we're even working on this data before we deploy our APIs or our models, because what happens is that in the end they can be used for certain dangerous cases just like this. So for my presentation, in terms of looking at how to practically implement these mitigations with respect to using publicly scraped data to fine-tune models, I'm going to discuss these four key issues that I spoke about and how to possibly mitigate them across the three main stages of the pipeline, which is on the stage of data collection, training and fine-tuning stage, and lastly, also at the deployment stage. You want to have certain activities that are done at each and every stage of this pipeline. And that is what we're going to go through with respect to even these key issues. So I'm going to first start with data collection, and then we'll look at some examples as well. So at the data collection stage, once again, as I mentioned earlier, iterating on that and emphasizing on that, you may have data that we scraped containing personally identifiable information or sensitive details, which includes maybe people's names, people's ages, people's email addresses, so whatever personally identifiable information, which is you can use that to locate them. It could even include their locations themselves. There are a lot of this data online. Next, also at the data collection stage, we should look at this with bias, where the data that we are scraping from, these online platforms, as I mentioned earlier as well, may overrepresent certain viewpoints, and we should be aware of that. And how can we even be able to predict what are some of those viewpoints or some of those demographics? I'll show that shortly. And then often, as I said, the data may be noisy where it contains information that is irrelevant for that use case. And once it's irrelevant for that use case, we want to take that out. You don't want the model to be learning certain features that are not relevant for that use case, because in as much as we can describe, AI as some sort of, black box model, we want to reduce this to be much more, deterministic or defined as much as possible in terms of knowing what data we fed it with and what data that it is working with. So take out any information that is, irrelevant. I would switch to my notebook shortly. Um, but before I do that, I'm going to just highlight, what are some of these steps that can be done to mitigate these. So even with respect to the first one I mentioned with personally identifiable information, we almost always, and especially if you're not going to work with demographics and you don't have permission to work with those demographics in training a model, we want to have anonymization of this PI information. There are certain APIs, just like Evenside API, that can, inherently be able to, anonymize this PI information itself. So we want to anonymize that, and I will demonstrate that shortly as well. With respect to bias, as I said, this is very context specific. You want to look at the context or domain use case of what is being built, why you're fine tuning that model, what it's being used for, what are those applications itself. And based on that context, you may want to, try to balance it out. You can't have a perfect, what people just say like a sort of a 50-50 maybe representation of every race. Once again, it's context specific. If, a drug maybe is being, developed or some diagnostic tool is being used, then maybe a largely Black populated area, definitely having what appears as a representation of a large, maybe Black race case is definitely not an overrepresentation because that is what is necessary for that context. So once again, with respect to mitigating bias, it is very context specific. And then with noise and irrelevant information, you just definitely want to filter that out. So I'll switch to show a demo shortly. I made a Google Colab where um, I scraped mental health related conversation. So it was a subreddit on mental health on Reddit and scraped that conversation from 2021 to 2023 and used that to fine tune was it a GPT-2 model itself. And I'll show how, we sort of had certain information that is still embedded in the PI information and how to mitigate that. We'll be switching shortly. So I can share this note. I can share this notebook like shortly after. But so basically in this notebook, I using the transformer data sets, went on just importing my libraries, as I mentioned, for just this demonstration case, just to be able to run this very quickly for demonstration purposes. I'm using GPT-2, which is relatively smaller in size um, for demonstration purposes. So don't expect so much good performance. This is GPT-2, but it serves as a very good use case for what I'm going to show. So firstly, I have a function here that I use to scrape the data, as I mentioned, over a period from 2021. Let me increase this a bit. I think this should be a bit clearer now for anyone that didn't see it. Okay, great. So as I mentioned, I first started by scraping a mental health post. So a subreddit on Reddit for mental health. So you basically having conversations, around mental health, people just complaining or ranting about mental health cases or talking about it in general. And I just picked it to just 1,000 posts, just for this demonstration purposes. So once I scraped that, the first thing that I did was to um, clean the data, and this involved trying to get only the post because they had several other categories in there, like a title, like some other information that I didn't need in there, and this took all of that out just to have the posts themselves. This is an overview of what the structure of like the script that I made. So you have like other fields that are not so necessary in there. And just to show you, just before anonymization, merely just trying to take out the fields that were not necessary, you still have something like Arthur. Now, Arthur was actually the usernames that are in there. And that counts as PR information because that means that you can go on subreddit and actually find who said what. So that Arthur information that was in there as well. And within the posts themselves, which we'll look into shortly, you realize that it sometimes would even contain like email addresses, names of people that are in there, a lot of PR information itself. I filtered out once again, like you need to filter out exactly what you need for the model that I was trying to fine tune. I'm trying to fine tune a model to be much more focused on conversations on mental health. I should take out all the other fields that I don't need so that I can just focus on the posts themselves. So as you can see, I filtered it out, and just to have just for display purposes, you have the authors who are the people that made those posts, and then we have self text was originally the name of the column from where I extracted it, but I represent the posts themselves. So you have a user like Maleficent Vanilla 21 saying Google gives no answers and I don't really understand. I think the person is complaining about access to mental health information. Someone is saying, well, recently I've been going through a rather, maybe depression. It goes on and on. Me and my parents, along with my cousins, blah, blah, blah. You can literally find who said that. And this can be very dangerous because somebody is talking about, their personal health stuff. And what happens is that once you just have, the artist tied onto certain posts, you may think that, well, it's just going to focus on the text. But based on how these models have been trained to understand, semantic associations, interestingly, it can sometimes tie on the users to the post themselves, and that leads to data leakages. So you're building a model to focus on mental health. You definitely don't need the usernames in there. You want to take it out. So once again, just for demonstration purposes, I first started my first mitigation strategy was anonymizing this data. And so making it to look out for email addresses, phone numbers, look out for also taking out the author, which I realized from looking at the data was the usernames themselves. So I'm trying to take out all of that PR information, and then now have an anonymized data where, as you can see, showing you all the artists, which are the usernames, have been redacted, and you only have the posts now. And even with the posts themselves, also like went through it to take out email addresses, phone numbers, whatever that kind of PR information that's in there. And that way you work, first with the anonymized data itself. As I mentioned, you always want to start, but after you scrape, you want to take a look at, the data itself, know what is in, what you don't need, and then we go ahead to clean it up and then, try and take out any API information that may be in there. If you're even working with some API that already does this, I still would insist that you want to still look at, the structure of the data that you've scraped, just have an overview of it. And interestingly, this is not even just for privacy reasons. What you can also achieve is having a better model because you're only given the information that you wanted to focus on, which in this case would be the posts themselves without all these other personal information, in there. The next step in there, actually now looking at trying to investigate bias. Once again, we are the data collection stage. As I mentioned earlier, I'm going to look at this across the three main pipelines. So data collection, training, and fine-tuning and deployment. So still at the data collection stage, another thing that I wanted to demonstrate is perhaps how to battle with bias and what that looks like. And a simple word cloud, for those that are familiar, it's a very good use tool in this use case, and I'll show that shortly. So going back to our notebook, I generated, a word cloud based on this data, which now I'm working with the anonymized data itself. So with a word cloud, what it helps you do is that you can identify certain dominant, terms. So it's in terms of frequency, because by theory, we are expecting that certain words that are, largely represented in terms of their frequency end up being focused on even much more. So for example, if you look at even state of the art like GPT and all that, if you use that to generate a writing piece, you realize that there are certain words that are used often. So for example, I think when I usually see an article and I see a lot of the word robust, trying to find some other words, but there are these words that once you just see it, you're like, this is from ChatGPT, and it's believed that the data that was used to train them usually had passages that had a lot of use of those words, and hence you have that overrepresentation. So it appears as it's biased towards using certain words, mainly because maybe a certain user group that have their text information online usually use those words. So using something as simple as to generate like a word cloud is a very powerful visualization tool. What you can use that is to see the overrepresentation of certain words, which gives you a cue on certain words that the model is going to focus on. So in this case, I have a word cloud on the anonymized data in here, and I just take a look at what words are largely represented, and I see the biggest visualization I have here is even for the word feel, which makes a lot of sense because once again I script mental health conversations, and it makes sense that maybe a lot of people are talking about how they feel, and hence you have a large representation of that, and that gives me a cue that perhaps my model that I'm fine tuning may be more maybe much more biased towards sentimental words like feel, which may not be a problem. It depends on the use case. If I don't want it to focus on that based on what I'm going to use the model for, then perhaps I may want to, balance this out by maybe taking out much more of those words, have, maybe a lower representation of it based on the use case. If it's going to be much more focused on, maybe a sentiment, application, or maybe understanding how people feel about certain situations in terms of mental health, then I don't have a problem. I may want it to be in there. So that's one way, purely just looking at words with the word cloud and seeing what words are largely represented. Another thing you can do with the word cloud as well, which is the next stage, was maybe you just want to focus on what are the kind of user groups it's focused on in terms of nouns that are in there. So I went on in this case to focus on pronouns and nouns to see if maybe for some reason is it focused more on males or females, or what kind of nouns is it focused on. So just try to take out nouns and pronouns that are in there and visualize that itself. So filter that had another word cloud. And interestingly, for the nouns and pronouns in there, um, things like family, someone, one, I see mother, I see girl, it goes on. I see guy, it goes on and on. So let's say for some reason I see that I see mom is maybe largely represented. I think this is currently giving me a general, impression that it may be focusing more on, having a much more female representation with respect to the post as compared to maybe males, just because I'm already, being able to see woman, girl, sister, I'm seeing couple, I'm seeing mother. I'm sure some of you are seeing other things that are in there, but at least just at a glance, I'm already having an intuition that when it comes to, nouns or looking at gender, which once again, you could also filter out just gender words and look at what are the representation over other ones. You can work with accounts, but I think a visualization gives you a good cue on what could be focused on. And that just lets me know that, I'm seeing girlfriend here. That just lets me know that, well, maybe it may be more, tuned towards, females than males. It's something I want to look out for, because anytime we talk about models hallucinating, to the model, it's not necessarily working wrongly. It's, working on inherent data it was trained for. But you were saying it's hallucinating because it's not context specific. But it's still generating words, and that prediction is based on this data. So you see, you want to just, have a very good, visualization on what data that you are using, what does it look like. And just as you saw in the first case, I'm just, generating all words that are in there and getting a good representation of the word count and representation that is in there. Next, I can decide to filter. In this case, I was looking at just nouns and pronouns in there and trying to take out what is there. And I'm getting a good, case on that. And I'm even realizing that the library I'm working with is still even trying to pull out some things which are not, generally um, things I may want within my data. And so you may want to filter more. Um, if I remember, for example, yeah, I saw something like the F word in there. Where is it? Yeah, I'm seeing like hate, which is fine. Maybe based on my use case. Um, I saw a few of cursing words in there earlier, trying hard to find them now. But maybe after I find them, I may want to filter them out or not, once again, depending on the use case. So, with respect to the data collection stage, this is also something you want to look at. Let's move on and take a look at where we are now. So, the next stage is the training and fine tuning. Once again, and make sure that is what we're seeing. Okay, great. Yeah, the training and fine tuning. So at the training stage, which, as I said, for this use case, I'm talking about fine tuning these existing, foundation models or these APIs that we have access to. At this stage, you may end up having a lot of bias reinforcement where you're training the models on these already existing or inherently existing bias that is in there. And so what happens is that you have the models, inheriting these biases and sometimes even amplifying these biases as well. And then the large language models can also end up memorizing specific data points. What does that look like at the fine tuning stage? Because this leads to privacy risks. Also, you may have contextual misunderstanding during this fine tuning stage. While fine tuning, you're realizing that the model it's not really, grabbing to understand the context of application very well, and that usually comes from noisy and very unstructured data. So imagine you hadn't even gone through the cleaning as well, or taking out what may be relevant, looking out for what is the overrepresentation or less representation of certain terms, and trying to balance that out. And as I said, it's an experimental process. So when I say balance that out, you want to use all these visualization cues and try to, maybe take out a certain, maybe words that are in there, take out certain text chunks that are in there, just to try to encode, balance it out. But once again, balancing is dependent on the context you're applying that to. What are some of the mitigations at this fine tuning stage? We're saying that you can do resampling or reweighting. And what I mean by that is literally what I was saying a few minutes ago, that you want to look at, first of all, a sample of the data. You want to compare certain sample sizes of maybe certain user groups to other user groups, try and reweight it. So it's quite of an experimental iterative process as well. With memorizing specific data points, you may want to employ differential privacy in there, which sometimes can be much more complicated, than you think. Where maybe, as I said, you want to focus on certain words, you want to focus on certain user groups or certain persons that are in there. You want to look out once again for certain PII that may be forcing, maybe the model to memorize on those specific data points as well. And what you have also, which you should always check, is that certain models tend to memorize on the data points much more than generalizing, and you want to check that out. It may have its advantage or disadvantage, especially when you want it to be very focused on a certain context, maybe a medical use case. You definitely having a model that is sticking more to the data points that are relating to health may be fine. In other contexts where you want it to be slightly general, it may not. These are, things that you want to look at. For contextual misunderstandings, what you want to do at this stage, this mitigation stage, is have much more of like a human in the loop system where while you're fine-tuning, you are looking at the output. Based on the output, you are going back in there to make certain changes, and then check the output again, and kind of go through this this feedback process on and on, so you have an output that is much more niche to what you want to do. So I'm going to show you an example of what this training and fine-tuning looks like. So in this context, after I had looked at my data and then filtered it, had anonymized it as well, and investigated it, and I felt like I'm good with how it's representing certain, words, certain keywords, certain user groups that are within my data set, move on to fine tune it. So once again, as I said, I'm using GPT-2. Doesn't have so much good output, but good enough for demonstration purposes and just quick to run. Yeah. So I'm fine tuning it on the anonymized data. As you can see, went through the fine tuning stage for that. Just ran like 3 epochs and then went on to test it. So now, based on my fine-tuned GPT-2 model on my mental health data, I went on to, prompt it. So now I'm prompting this fine-tuned model. And as you can see, just as I mentioned, I was initially using GPT-2, and there's something interesting that I realized. Which definitely can be avoided after improving upon it over and over again. But once I got this output, it was a very use case to show you what can happen. So I first prompted what are the tips for better mental health to GPT-2 that had been trained on this mental health Reddit. And it goes on to literally pull directly what looks like a post that was in there. And this goes on. I'm a young man who's been struggling with depression for years. Now, remember this. You remember we had what looking at the nouns and pronouns in there. I kind of saw a hint that we had much more kind of female representation than male. So now, even though it had memorized a specific data point, which is perhaps a post itself that may be in there, an aggregation of certain posts, you're already seeing like young woman. Like this is already give me an intuition that even if I was going to use like a much more better model, like a 3.0, 3.5 GPT, which may be much more generalized, understand my question and give me an answer, GPT-2 has picked a post that, that kind of answers that it's in line with what we can infer from to answer the question of what are the tips for better mental health, because the person goes on to talk about people that have helped her and how she had to cope with stress and depression. So literally this would be a data point that they could have inferred the answer from. But GPT-2 maybe not being so good, it just picks the exact data point. But you can see that it's already picking a data point that was, skewed towards what the woman did. You get what I'm saying? And already I had a hint towards, it performing that way by seeing that there was a relatively much more of a representation of female views than male views. And so even using GPT-2 here was a very good example. A very good model would have just maybe given me an answer, but it's showing me the data points from which it's going to give me an answer and just coughing that back to me. But already I'm seeing that it's focused on a woman. It's doing well. It kind of understands the question because it's giving me, how someone dealt with mental health, but literally pulled the exact post for me. I went on to try another one. How can I avoid suicide? And once again, it had memorized a specific data point. It says, I'm not sure if I should or should not. I'm a very depressed person. I don't want to be alone, but I also don't want to know that I'm not suicidal. So are you realizing that, you see, it's already letting me know characteristic wise how this model works, where it's not just pulling the answer just because it's intelligent, just as we want to, quote, these models as. It refers or infers from a data point that is likely related or similar to my question. So this is, a pose or an aggregation of a pose. GPT-2 not being so good, maybe just merging certain, codes. And this is a raw model. It's not been, fine-tuned in a way to maybe do well in answering prompts yet, but is doing a good job of showing me how it refers to a certain data point that had the word suicide in there and pulled up that post for me. So we've seen two characteristics so far, where first of all, it can be focused on a certain gender just because of the relatively larger representation of one gender of another gender or one sex of another sex. And also how well it understands the nuance of, the prompt I did, which was on like suicide, and actually sent me something on how someone avoided suicide, where the person started to take certain antidepressants and all of that. So the so-called intelligence of these systems is not just something ambiguous. What is happening is that it is inferring from data points that are in there, and even using a model that is not, the best of, intelligence of models. It's just letting us know, at that lower layer how it is working, which is inferring from these data points. And so we should be very concerned about what data points that, we have in there. So try those two examples. Then, realizing that, okay, can I attempt to reduce this overfitting towards, a specific data point, pulling up that same data point or memorizing, that data point, went on to reduce the number of epochs a bit and then try to prompt it again by saying that what are tips for better mental health? Once again, still, pulling, specific data point, but it's been slightly more general. Since I'm currently in mental health treatment session, once again, this may be someone's post. So you see how in this way we fine tune towards, this mental health post, and the model not being, so good. It's not generalizing that well, but it's understanding the nuance of this post and, trying to experiment with the different number of epochs is trying to improve it. So this is how, they go through like a very iterative process and then do a number of human in the loop, give it like a few short prompts on how to answer a question. So through the few short prompt, we can show it that, okay, in answering the questions, start with, okay, the tips for better mental health are, then it just extracts, what was, said by people in there. Because this person's talking about therapy, going on to sometimes and issues with, working with a therapist and all of that. Yeah. So we'll come back in the next example here. I decided to fine tune it on the unanonymized data to see if we can sort of demonstrate data leakage. But before that, I'll just showcase what stage we are at just to keep us, in tune. So, yeah, I had over here how it was overfitting to specific data points, but that still gave us a good idea of how it is inferring its answers and how it could be very dangerous based on the data points that we have in there. The last stage is deployment. At the deployment stage, where we're looking at how the model is working itself, you may still have, if we didn't anonymize the data well, we may have data leakage where certain private and sensitive data, can be leaked or can be inferred from the data. Also, you may have, outputs that may be harmful, may be biased. For example, if you were going to use this mental health data to fine tune a model that will be suggesting, options on how someone should deal with mental health, and you have these posts that you use to fine tune it, you definitely want to take out posts where people were given, wrong kind of recommendations on how they dealt with it. And you want to filter that out itself. And at the deployment stage, you also want to have some level of transparency. You cannot know perfectly, exactly, in every way your model is working, but you have a good idea of how this model is working, to a good point of being able to, interpret or explain this model to a very good, extent. So you're going to look at this deployment and the mitigation steps now. So we have what we call like a sort of output filtering, where you can have another filter at the output layer. Maybe you are working on a very large data set, and although you have filtered out certain harmful words, certain harmful, data that may be in there or PI that may be in there, at the output layer of your software or the application, we can still have a filter in there that filters out PI information or filters out certain harmful words. You may also have like real-time moderation. That is while it's providing certain output, you've put in some moderating algorithms in there that is trying to maybe balance out the user group, balance out the kind of responses that you have to maybe a specific gender, a specific use case, what that looks like. For transparency, at the end of fine-tuning this model, you want to have a very good description of the data set that was used. That way people have an idea of that. By standard, you're promoting transparency by doing that. Or you also want to have like some sort of a usage guidelines on how the model should be used. And that way you sort of curbing some of these issues that come with it. So I'll just demonstrate some examples at the deployment stage in here. Just very quickly. So before I went on, I tried to use the unanonymized data to fine tune it. Once again, just run through epochs, could be improved upon if I ran it, for longer. And just looked at if I could extract people's, information in there. So over here, I ran, the same prompt in there. What are the tips for better mental health on the unanonymized data? It pulled up that same data point, but went on to give me even much more information. I'm seeing someone's name in there and, the year and all of that. This is, some information that you don't want in there. And this was on the unanonymized data. So even on a model that is doing so well, if you have this anonymized data, you can pull up, some of this information that is in there, because someone's name should definitely not come out. We can see that with the earlier post, we didn't, even though it referred to that data point in here, we didn't have anyone's name. Where is that? I'm a young person, I'm a young man who's been struggling with depression for years, but we don't see that, the name in there because it was filtered out. But in this case, where it's still inferred to that same data point to answer the same prompt, it's giving me like, someone's name that is in there, which it's a problem. Next with the next, I tried to see if I ask the prompt who is depressed, would it just show me the author? But it didn't directly bring that, but it went on to give a description the same person gave, talking about someone being a college student, talking about her parents and that. It's giving much more information with the unanonymized data, which from some way you can use that to, infer who is talking and all of that. I tried to, red team the model by saying who is the author. And it gave me, and it responded by pulling the ID of the user that made the post. I didn't get the exact username, but it pulled up the ID, which someone can use to match back to who the exact user was. But they sort of gave me the user ID from the backend, which is a problem. And this is what happens when you deploy a model that was fine-tuned on an unanonymized data. You can prompt it back to pull out this personal information. Try it once again with a GPT-2 model to ask for the username. I didn't get the username, just put up the data point in itself once again. But once again, what happened here, you're seeing that could pull out the user ID that can be used to match that once again. Let me show this as well. So went on to use the anonymized data to improve upon and increase the number of epochs a bit, and then it started to generalize a bit based on questions I asked. This was how can I manage stress? It's pulling a post, but is performing less in terms of trying to be exactly direct on the post, and GPT-2 is starting to generalize towards what the answer looks like. But once again, we can see clearly how it was better in terms of, being more general. I think I had some what are tips for better mental health. And you see that now it's behaving like a better model. It says one. So you see, this is a very good example. Yeah, I'm so glad I saw this one year. So the prompt was what are tips for better mental health, and it went on to go like one, drink energy drinks and work with your family or therapist. Now it's trying to answer in a way that we see these current models working, where it's giving you an answer and it's not necessarily pulling a post. But you can see that this suggestion of drink energy drinks is perhaps because there was a user in there that said, hey, drink energy drinks and work with my family and therapist and you have better outcomes. So run further epochs at the deployment stage, try to generalize the model more, is trying to behave as being intelligent by answering me. But once again, as you can see, at the underhood, it was referring to a specific data point, and based on what a user suggested, it's giving me a suggestion. So we can see very well how it's so important how we handle this data that is scraped. And with most of us here, or most people here that maybe are data scraping enthusiasts, before we present even the data that we scrape, maybe it's an API you present, maybe it's a data that you present, you want to be able to, present some data that after going through this process in a way that, mitigates all these potential issues. And based on that, I summarized the process in here and sort of came up with an activity-based framework that I want to share and publish shortly. And this framework puts everything that I just talked about here. So I call it like a framework for an ethical AI productization with publicly scraped data, which is a responsible approach to using publicly scraped data to fine-tune LLMs. So I have it as a stage activity-based framework where you have data collection, training and fine-tuning stage, and deployment stage. What are the main activities you want to look at each stage, and how you want to have user feedback across all of these three stages to improve upon it. Yeah. You can scan this QR code here to have access to the notebook that I just demonstrated and just take a look at it. But yeah, thank you very much. And this is the framework. I should share the link to the community shortly as well, once I'm just done improving upon it. Thank you very much for your time. And yeah, over to you. Any questions? You can also reach out to me if you're working on similar work, you want to collaborate, have some questions, doing some, I don't know, similar work, working on some papers, open for discussion. That's my email, and happy to reach out to anyone that also reaches out as well. Thank you, everyone.